All right, hello and welcome. Today we are going on a little adventure to decode one of the most important shapes in the entire universe. Seriously, it's everywhere, from the ancient pyramids to the phone you might be holding. You ready? Let's deconstruct the triangle.
Okay, I want you to think about this for a sec. A delicious slice of pizza, one of those giant Egyptian pyramids, and maybe a yield sign you see on the street corner. What's the one thing that connects all of them? Well, if you guessed that they're all triangles, you are 100% right. This simple shape is like a fundamental building block of our world, and today we're going to figure out exactly how it works.
So, to really truly understand the triangle, we need to unlock its three core secrets. These are basically the ingredients that make a triangle, well, a triangle. Let's get into it.
And here it is, secret number 1. It all comes down to the magic number 3. A triangle is a closed shape. That just means there are no gaps in it, and it absolutely must have 3 straight sides. Now, where those sides meet, they form 3 corners, which have a fancy name, vertices. And inside those corners, you get 3 angles. So 3 sides, 3 vertices, and 3 angles. Pretty simple, right?
Okay, so now that we know what a triangle is, let's talk about what a triangle has to do. See, every single triangle that has ever existed, from the tiny one you draw with a pencil to the biggest ones in the cosmos, follows 2 unbreakable rules. I kind of like to think of them as the triangle's superpowers.
Let's start with the angles inside the triangle. If you were to measure all 3 of them and then add them up, would you get a different number every single time? Or is there one special magic number that they always have to hit?
That's it right there, 180 degrees. Not 179, not 181. It is always 180. This is superpower number 1.
This rule has a name. It's called the angle sum property. And a really good way to think about it is like this. Imagine every triangle gets a budget of 180 degrees to share between its 3 corners. It can split it up in all kinds of ways. Maybe it's 3 equal angles, or 1 really big one and 2 small ones, but no matter what, the total always has to be exactly 180.
Okay, superpower number 1 is in the bag. Now for our second big rule. Let's talk about the sides. If I just gave you 3 random sticks, all different lengths, could you always form a triangle with them? Let's see. Just take a look at these 2 examples. On the left, with sides of 5, 6, and 7, everything connects perfectly to make a triangle. But look at the one on the right. Something's wrong. The 2 shorter sides, the 2 and the 3, they just can't reach each other to close the shape. So why does that happen?
This brings us to superpower number 2, the triangle inequality rule. I know it sounds super complicated, but it's actually really simple. All it means is that for any triangle, if you add the lengths of any 2 sides, their total must be bigger than the 3rd side. In our failed example, 2 plus 3 is 5. Is 5 bigger than 8? Nope. And that's why the triangle just collapses.
Okay, awesome job. We've got the definition down and the 2 big rules. Now for the really fun part. Let's meet the different members of the triangle family. First up, we're going to sort them out based on how long their sides are. First up, we've got the equilateral triangle. Just think equal. This is the perfectionist of the family. All 3 of its sides are the exact same length. And because of that, all 3 of its angles are also the exact same, 60 degrees each. And hey, what's 60 plus 60 plus 60? 180. See? That rule always holds up. Next up is the isosceles triangle. This one is like the 2-of-a-kind triangle. It has 2 sides that are equal in length. And because of that, the 2 angles across from those sides are also equal. One side is kind of the odd one out.
And last but not least, we have the scaling triangle. This is the free spirit of the family. Nothing matches. All 3 sides have totally different lengths, which, you guessed it, means all 3 angles have different measurements too. It's completely unique.
So here's just a super quick summary of that family. Equilateral, all sides and angles are equal. Isosceles, 2 sides and 2 angles are equal. And scalene, no sides or angles are equal. That's a great way to remember them.
But wait a minute, there's another way to sort the triangle family. Besides looking at their sides, we can also classify them based on what their angles look like. First in this group is the acute triangle. An easy way to remember it is that all its angles are little and acute. Every single one of its 3 angles is sharp, or acute, which just means they're all less than 90 degrees.
Okay, now for a very, very special case. There's one angle that is so important, it gets a whole type of triangle named after it. It's that perfect L-shaped corner, a builder's best friend, the 90-degree angle.
This creates the right triangle, and it's defined by having one angle that is exactly 90 degrees. This triangle is so special, its sides even get their own names. The two sides that form that perfect corner are called the base and the altitude. And that long, slanted side across from the right angle, that has the coolest name of all, the hypotenuse. And it's always the longest side.
And our final family member is the obtuse triangle. So if an acute angle is small, and a right angle is exactly 90, an obtuse angle is big and wide. It's greater than 90 degrees. So an obtuse triangle is simply any triangle that has one of these big, wide angles inside it.
All right, that was a lot of information, I know, but you did an amazing job. We've defined triangles, we've learned their superpowers, and we've met all the different family members. So let's just put everything we've learned into a handy toolkit that you can take with you.
Here are the 4 biggest ideas to put in your toolkit. Number 1, the angle rule. All 3 angles always add up to 180 degrees. 2, the side rule. Any 2 sides added together must be longer than the third. 3, we can sort them by their sides, equilateral, isosceles, and scalene. And 4, we can also sort them by their angles, acute, right, and obtuse. That's pretty much it.
So, here's my challenge to you. Now that you're basically a triangle expert, I want you to keep your eyes open. Look at bridges, buildings, signs, maybe even a sandwich you cut in half. How many different types of triangles can you find out there in the world around you? You are going to be so surprised at just how often our favorite 3-sided shape shows up. Thanks for watching.